Now, we will pass to the second part of the exhibition, Mathematics in Greece. To start a character pro from this time, I will talk about the situation of mathematics before the Greeks.
Hi, I am Thales of Miletus, one of the most important mathematician in history. Greek was one of the most important period of mathematics. Before I appeared, the Babylonian had introduced the measuring system of time that we have nowadays. They divided the days into 24 hours, hours into 60 minutes and minutes into 60 seconds. They had already set out problems about daily calculations, contracts and loans of simple and compound interests. In geometry, they knew the triangle's properties, and in algebra problem is up to 4th degree. After them, came the Egyptians, who had already knew the natural numbers and the positive rationals of numerator 1. They also provided the most accurate approximation of pi, 3.16, the one we use nowadays. And they solved equations of 2nd degree and square roots to apply them to the area's problems. Although mathematics were already developed, they presented some difficulties, and its usefulness was only practical, measuring, constructing or counting. And they used the inductive method that consists of arriving at a general conclusion from a set of concrete cases.
However, the Greeks were worried about reflecting on the nature of numbers. For example, Pythagoras thought that the first element of everything, the arche, were the numbers, about the nature of mathematical objects, geometry, etc. They converted mathematics in a rational and structured science with properties that are demonstrated, and in contrast to the previous ones, the Greeks used a deductive method in which a conclusion is reached based on the information that we already had. The contribution of the Greeks to mathematics is the greatest advance of this science in the period between prehistory and the Renaissance. The three classical problems of Greek mathematics are: the first one, the square of the circle. It is the unsolvable mathematical problem of geometry that consists of finding out with only a ruler and a compass a square that has an area that is equal to that of a given circle. The second one is called the duplication of the cube. The problem is to find out by only using a ruler and a compass the side of a cube such that each volume is twice the volume of another cube of a given side. And the last one, the trisection of the angle. The problem is to find out an angle whose measurement is 1/3 of another given angle by only using a ruler and a compass. First period. It is believed that Greek mathematics began with Thales and Pythagoras, who were inspired by the ideas of the Egyptians, the Mesopotamians, and perhaps the Indians. Schools. The Ionian school, founded by Thales of Miletus around 16 before Christ, was the first to begin the scientific study of geometry. The first demonstrations of geometrical theorems are attributed to him by the logical reasoning. Later, it was the Pythagorean school, founded by Pythagoras around 550 after Christ. Numerous mathematical discoveries are attributed to him, among others the demonstration of the well-known Pythagorean theorem. It is said that in a right triangle, the hypotenuse square equals the sum of the squares of the legs. Module. In addition, they develop a first group of 4 mathematical disciplines: arithmetic, music or arithmetic of musical intervals, flat geometry, and spherical geometry. The Pythagorean doctrine held that all the reasons governing the world should be reasons of integers or fractions. These views were opposed by another important Greek school, the Elean school. His criticism took form in the works of Parmenides and the famous paradox of Zeno. Zeno tried to show that reality is one and invariable, and that of movement is something unreal. Its paradox explored the limits of nature, understood as physics. Here is an example: the argument of the stadium. A runner cannot travel a specific distance in his life, since it breaks down into infinitive successive intervals of length, each of which must be traveled before traveling the next, and without ever going to go through the last, because there is not, since the sequence of intervals is infinity. Movement does not exist. That is, you cannot travel an infinitive space in a finite time. Later, we can mention the first school of Alexandria, whose main representative was Euclid, one of the characters that have most influenced the history of mathematics. His most important work is the treatise The Elements, whose content and structure has been studied in schools and universities until very recently, and it was transcendental in the development of geometry. The Euclidean method comprises, in the first place, a general theory based on axioms, properties that we admit as certain without needing proof because they are evident, the postulates of Euclid. The 5 postulates of Euclid included in his work Elements are: given 2 points, you can draw a line that joins them. Any segment can be extended continuously in any direction. You can draw a circle with center at any point and any radius. All right angles are congruent. If one line intersects 2 other formings on the same side of the second, 2 acute internal angles, those 2 prolonged lines are indefinitely cut from the side where the angles are. For a point outside a line, you can draw a single parallel to the given line. Let's quote Archimedes to finish this brief tour. He was the greatest mathematician of antiquity. It is attribute: the calculation of P by successive approximation, the determination of cylinder and sphere volumes, the quadrature of the segment of the parabola, the use of static movements and center of gravity, etc. These discoveries opened the way to mechanics and integral calculus. From this moment, the Hellenic science began to decline. Second period. After a long interval during which progress is scarce, another fruitful period emerges due to the Second School of Alexandria, in which stand out Nicomedes, Ptolemy with his famous system of the world, Diophantus with his great arithmetical investigations, and Pappus, whose work collection is composed of 8 books which contain a series of problems that introduce important geometric notions such as the focus of a parabola or the gatline of a conic and the sentence of many theorems, among them the Pappus theorem that relates surface and volumes of solids of revolution with their respective centroids.
This last part of the exhibition has just finished. We remind you that you should return to the back part of the card to listen to the last QR code.